retailer receives shipment from three suppliers. The delivery cost per supplier are as follows in these three equations. Okay. Now, it says that find the unit cost per shipment from each supplier using Cramer's rule. So Cramer's rule is all about matrix. Yes, please. Um, Cramer's rule. Okay, so these are the equations. The first one is 2x plus 3y plus z being equal to 180. So 2x plus 3y plus z being equal to 180. The second one is x plus 2x x plus 2y plus 3z being equal to 150. So x plus 2y plus 3z 3z being equal to 150. Then the last one 3x plus y plus 2x, sorry, 2z being equal to 160. Please, you get it? Okay. So if a question is being given you like this, what is the first thing? You said using the Cramer's rule. So what was the first thing? So you would have to first resolve it in a matrix. Okay, in a matrix form. So here you get 2. This side is x, this side will be y, and the other side, the last side will be z. Okay. So the coefficient of the x will be written. So that's why I wrote 2 here. So the second one will be 1 and the last one 3. So here 2, the y own will be what? 3, 2, and 1. Then the last one will be 1, 3, 1. Please you understand? Then we write x, y, z in this way. X, y, z. Now, the reason being that when we multiply, this is how it becomes. We multiply x by 2 here plus y by 3 plus z by 1. If it is multiplication, like the x here will multiply this 2. So we get what? 2x. Then we say plus this y will multiply the 3. So 3y. Then the z here will multiply the 1. Then we say plus z being equal to 180. So we will say here 2 is equal to 180, 150, 160. Please you understand? Hmm. So this is how you resolve it into a matrix. Now, this matrix, the 3 by 3 matrix becomes the main matrix. So you can say let's the main matrix be A. So 2, 1, 3, 3, 2, 1, 1, 3, 1. So that becomes your A. So when you have that as your A, when you have that as your A, what you do is this. You find the determinant of, no, 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 no. Now that you are you found this. Okay, you just need that as your main matrix. Okay, so you use that main matrix to find the determinant of that main matrix, and the determinant of the main matrix. Oh, I want to see the figures. Ehen. So the determinant of the main matrix becomes 2, 1, 3, 3, 2, 1, 1, 3, 1. Then you repeat the first two. So 2, 1, 3, 3, 2, 1. Oh, I'm saying that my distance is not responding. So 3, 2, 1. Right. Good. Now, the determinant, we find it diagonal. Okay. Diagonally in the sense that 2 will multiply this and multiply this. This will multiply this and multiply this. This will multiply this and multiply. So the determinant of A becomes 2, 2 times 2 times 1, right? 2 times 2 is what? 4 times 1 is still 4 plus, yes, plus 3 times 3 times 3. That's, I think, 7 plus 1 times 1 times 1. Then you do the subtraction. So the subtraction is the other diagonal. That's the opposite of what we just did. Okay. So that one too, we do another diagonal, and that diagonal becomes the opposite of what we just did. So that one is like this. Mm-hmm. So 1 times 2 times 3 is what? 6, right? Any which way, since we are going to add, it is commutative. So any which way we get it right. Okay. So 2 times 3 times 1, 2 will give you 6. Then 3 times 1 times 1 will give you 3. So when we add these, what do we get? 28 plus 4, 32 minus 6, 6. So 6 plus 6 is 12 plus 3, 15. Right? So please, what do we get? Yeah. Yes, please. I think it's 17. Yeah. So this becomes the main matrix. Okay. So when we are done with this, we find the determinant of matrix X. So we find matrix X, and this becomes matrix X. Now look at how you see that this side. I told you that this side of the matrix are coefficients of X, right? So to get matrix X, you replace the coefficient of X with the answer. That's the 180. You know that the equation is equal to 180. The first one is equal to 180, second one is equal to 150, the last one is equal to 160. So we replace the coefficient of matrix X by the figures that they are equal to, the figures that there. um, simultaneous equations are equal to, or the systems of equations are equal to. Please, do you understand? So here becomes like, let me say, 180, 150, 160. Then we repeat the rest. So we repeat 3, 2, 1, 1, 3, 1. Please, do you understand? Yes. But because it is determinant that we are finding, we repeat the first two. So here becomes what? 180, 150, 160, and what? 3, 2, 1. Is that you good? So determinant of matrix X becomes 180 times 2 times 1, which is what? Times 1. Now, the second one too becomes, oh, sorry, 3 times 3 times 160. Yeah, yeah. So 3 times 3 times 160, which is what? Times 160. Because this is the crossing. I don't want to be crossing, otherwise a pay no basa. I did you can be crossing from your end like this. Hmm. So 3 times 3 times 160 becomes 1440, isn't it? Then 339, 9 times 160. Yes, that's the first one. And I in 160. So 180 times 2 times 1 give us 160. This 160. Yes. So the last one, which is 1 times 150 times 1, will give us 1. Then we subtract. The subtraction 2 becomes 3 times 150 times 1, which is 450. The second one will be 180 times 3 times 1, which is 5. I'm writing here 540. Then the last one being 1 times 2 times 160. So 160 times 2 is 320. So please you understand. So therefore x becomes 360 plus 1440 plus 115, which is 1950 minus 450. 1950 minus 450 plus 540. 170. Mhm. Oh no, add it again. Mhm. Mhm. No, I'm not getting that. Who use a calculator? Hey, I'm not getting that. So when we subtract the 1310 from the 1950, we get 640. So this 640, we then determine our matrix X. No, our X value. And X value becomes the determinant of X divided by the determinant of the main matrix. So the determinant of X is 640. And that of the main matrix is what? 17. So the answer becomes, it becomes 640 divided by 7. Hey, I'm getting 37.64. So 37.65 approximate. Okay. Hello. Hello. This time around we are going to change that of y with the answer. So y's coefficient will be 180, 150, and 160. Please you understand? Then x will still be 131. Then we repeat the first two. So 213, 180, 150, then 160. This is how we go. Okay. So from here we can find the matrix. So y becomes this, this, right? The second one too will be this, and the last one this and this. So 2 times 150 times 1 will give you 300 plus 180 times 3 times 3. 180 times 3 times 3 will give you 1620. Then the last one, 1 times 1 times 160 will give you 160 minus that one too will be the 180. This is 180. So this way, so that one will be 180 times 1 times 1, which is 180. The second one will be 2 times 3 times 160. So 2 times 3 times 160, which is 960. Then the last one will be 1 times 150 times 3, which is 450. This is how you go. Okay. So therefore, matrix Y becomes 300 plus 1620 plus 160, which is 2080, minus 180 plus 960 plus 450, which is 1590. So when we subtract, we get 280 minus 1590. That's 490. Good. So to get the value for y, it becomes the matrix y divided by what? The main matrix. So why we are getting 490? So the main matrix we got 17. So it becomes 490 divided by 17, which is 28 points. Ideally, matrix question you shouldn't be getting decimals, but I don't know. That's why I said it's either he has not checked the question, because the first question even we made a mistake. I said there was a mistake in it. Really didn't make a mistake. There was a mistake. So I think um, now. Oh, okay. That's what he said. Two decimal places. Okay. Well, then I think me. You see, even I didn't know, but look at, I'm always leaving them in two decimal places. Have you seen it? Yeah, because I know the lecturer that I'm telling. So okay, let's continue. So we do the same for matrix Z. So with matrix Z, that one too, the y's coefficient, the x and y's coefficient will be retained, but that of x will be z will be replaced by the 180, 150, and the 160. Then we repeat the first two, so 2, 1, 3, 3, 2. Please, is it good? So the determinant becomes 2 times 2 times 160. This and yeah. So 2 times 2 times 160. 2 times 164. 4 times 160 is 640. Yes. 339. So okay. So the second one becomes 3 times 150 times 3. So 3 times 3, 150 times 3 is 450 times another 3. Good. So 1350. 180 times 1 times 1 will give you 180. Then here we do the reverse. So here will be 3 times 1 times 160. 160 times 3. I think it's 480, right? Yes. Now the second one becomes 2 times 150 times 1, which is also 300. Then the last one, 3 times 3 is 6. 6 times 160, 180. 1008. Please, did you get that? So we add them. So 640 plus 1350 plus 180. We are getting 2170 minus 480 plus 300 plus 1080. And hey, yes, so 1000, 2007, 170 minus 1860. That's giving us 310. So therefore, our z becomes the determinant of z all over the main matrix. So the determinant of that is 310 divided by 17. That's the main matrix here. Okay. And that will give us, yes, 18.24 as our final answer. Please, are we good? Okay. Question 3-2 is a matrix question. And that one, or I think it was a matrix question. And that one, it is simple but tricky. Look at something. Yes, simple but tricky. Uh, It's saying that a manufacturer a manufacturing company uses three types of raw materials and two products. The consumption matrix is P equals to this. So let me write it first. That's P is equal to 245. The other one is 312. It says that for each row is a material, each column is a product. If the unit cost of material is Q, uh, now the question is saying that, oh, where's my mouse? This question is saying that, look at read, oh, you see, when you read, you will get to see that it says that now each row is a material, each column is a product. If the unit cost of material is this Q, okay, unit cost is one cost of material is Q. This is the unit cost, and he's saying that find the cost to produce each product. Please, do you understand? This is the cost. They've given you the cost of material as Q. Okay, is equal to, these questions are optimization. 0.5 x squared plus 5x plus 200. And the revenue function is 35R. Sorry. So revenue function is equal to 35x. So this C here stands for cost and the R stands for revenue. What is the question? It says that find the profit function. B, how many units will maximize profit? C, what is the maximum? Very simple. You know profit. Profit is equal to what? The revenues minus the cost, isn't it? So to get profit, Well, let me not bring the x. Otherwise, to get profit becomes 35x. That's the revenue minus the cost. So the negative will affect everything in the bracket. So we get this 35x minus 0.25x squared plus, oh, sorry, that one will be minus 5x minus 200. So we group like terms. This and this, they are like terms. So we can say that we get minus 0.25x squared. 35x minus x squared will give you minus 30x minus 200. Please, you understand? You don't understand? Okay. I'm saying that from there, the negative will affect everything in the bracket. So now this one will be negative, this one will be negative, this one will be negative. That's what I've done. Yes, because 5x plus 200, I'm saying that this negative here will affect everything in the bracket. So every plus will become minus. Please do you understand? Good. Now from here, 35x and minus 5x, they are like terms. They have an exponent of 1, 1. So we can subtract. That's why I said 35x. We will subtract the 5x from the 35x, then we'll get what? 30. You let me group like terms and show you. So from here we group like terms. So here will be 35x minus 5x. Then here will be minus 200. Okay. So from here you get minus 0.25x squared. Now 35x minus x minus 5x will give you 30x minus 200. Please you understand? 5x will give us 30. Okay. So this becomes the profit function. This profit becomes equal to minus 0.25x squared plus 30x minus. So that profit is maximized either at x being equal to minus b over 2a, or you using this is when you want to use a formula. Okay, this is when you want to use a formula, but you can also decide to use the differentiation approach, whereby you differentiate the profit. So you take the profit. This is the profit. So yeah, let me rewrite the profit here. Profit is equal to minus 0.25x squared plus 30 minus 200. So the first one is saying that over 2a. 2a, not 2. Yes, please. Over 2a. Now, how we are using this. This is for the optimal level of the x, or the x value that will optimize the equation. I told you that if it is quadratic, a negative is like an n10 and a positive is a u10. So negative will give us a maximum turning point. Do you remember? And I told you that this occurs at the first derivative being 0, or the value of x being equal to minus b over 2a. I don't know whether you remember. 2a. So I told you that we can use the differentiation to find it, or using this formula minus b over 2a to also find it. So that's what we are coming to, the optimal level, or the maximum or minimum. That's the optimal level. So for if you are using this, then we can say x is equal to, now we have to determine our a. Our a is the coefficient of x squared. So coefficient of x squared becomes minus 0.25. Our b becomes the coefficient of x, which is 30 here, and our c is the constant number, which is minus 1. Please, are we good? So therefore, it becomes minus b. X becomes minus b, which is minus 30 over what? 2a minus 0.25. Minus 0.25. So here will give us minus 30 over minus 0.5, and that should give us the optimal. So I think the answer is 0.25. 0.5. Yes. So this is the quantity that will optimize our profits. So if our x is 60, if our quantity is 60, we'll get the optimal profit. Another approach, let me use an alternative. The alternative is use alternative. You can say that, the profit was this, plus 30x minus 200. So you differentiate. The profit over the x will be equal to what? This 2, I told you that it will come and multiply this differentiation, minus 0.5 x. Then the 2 will be reduced by 1. Please, you remember. Then the 32, the x here has 1. It will come and multiply 30. That will still give you 30, but the x will reduce by 1. Then the constant, anytime you differentiate the constant, you get 0. So therefore, the pi over the x becomes minus 0. Oh, minus 0.5 x, because 2 minus 1 will be just 1, plus 30. Now x to the power 1 minus 1 will give you x to the power 0, and any number to the power 0 is 1. So 1 times 30 will still be 30. Then this will be 0, so it's out. So therefore, our div please, do you understand? Okay. So therefore, our differential becomes this: minus 0.5x plus 30. And I'm saying that at optimal level, that the pi over the x is equal to 0. So we can say that 0 should be equal to minus 0.5 x plus 30. So from here, we take this to the other side of the equation. We get 0.5x being equal to 30. We divide here by 0.5. We divide here by 0.5. We cancel out. So x will be equal to what? 60, which is 0.30 divided by 0. Please, how we go? Okay. The question is saying that we should find the optimal profits. Now, this is what we got for profit function. Now, to find the optimal profit, we know that profit is maximized when x is 60. So when x is 60, pi x is maximized. So for maximum profit, so therefore the maximum profit becomes anywhere you see x, we are putting 60 there. Okay. So here too will be 30 into bracket 60 minus 200. So therefore, profit at maximum becomes minus minus 0.25 times 60 plus 30 into bracket 60 minus 200, and that will give us 1000. Yeah, this is the C. So therefore, the maximum revenue, sorry, the maximum profit is, was it dollars or cedis? Me, I don't remember. 1580. I don't think they brought currency. So therefore, the maximum profit is that. That's the C. So the C, you just put the maximum output level in the function. Yes. This is not. Let's do. Right. Okay. Also, you can write all this one. Oh, that. Um, I'm So I'm recording it, so I'll send you the YouTube link, then you will go through. I believe